The size n of the population of a small island may be modelled as a continuous variable. At time t, the rate of increase of n is directly proportional to the value of n. Write down the differential equation that is satisfied by n. Show that n is equal to a to the kt where a and k are constants. Given that n is 100 when t is 2 and that n equals 160 when t is 12, show that k is equal to 0.047, correct at 3 decimal places. Find the size of the population when t equals 20. So let's have a little look at this then. I've summarised the question here. Population n of a small island, and we've got these information here. So for the first part then, it just simply says write down the differential equation described in the above. So it says the rate of increase in n, well that's the n dt. And that's directly proportional, so it's equal to a constant of proportionality times n, because it's directly proportional to n. So there's our differential equation written down. Show that this, so we need to solve this. So part B now, solve this differential equation. So B, separating the variables and integrating gives, move the n down to be with the dn, 1 over n dn is equal to, leave the alpha as is, move the dt up to be with it, separate the variables and integrating gives. So that tells us then, this is log n, when you integrate this. This integrates to alpha t, doesn't it? Now plus a constant of integration, which I'm going to write as a log value so that we can simplify it. So let's write that as ln c. So now move this over. So L log of n, when it becomes a minus, it's the same as dividing these two values in the logarithm, isn't it? Divide your minus top, take bottom, so that'll be log n minus the log c. That's equal to alpha t. Now this is log base e, so let's unwrap the logarithm. N over c, then log base e, the base number swings down, hits that in the air, that's how you unwrap it, e to the alpha t. So that tells us then that n is equal to c e to the alpha t. So here it's of the right form, and we can say that the a value and k are constants, a to the kt. So a has the value c in this, and k has the value alpha. So n is equal to a e to the kt is fine. So that's part B done. So given that n is 100 when t is 2 and n is 160 when t is 12, show that k is 0.047. So n equals 100 when t equals 2 and n equals 160 when t equals 12. This one, put it in, 100 is equal to a e to the kt, and that's 2, so that's 2 lots of k. Put this one in now. 160 is equal to a e, and it's going to be kt, and t is 12, so that's 12k. It's easier on the eye to write it as 12k rather than k times 12. 2 divided by 1 will get rid of the a's and we can solve. So 2 divided by 1 gives, so what have we got then? 160 over 100 is 1.6, and that's equal to, the a's will cancel, and it's e to the 12k over e to the 2k. Divide your minus the indices, top take bottom, so that's e to the 10k. Take logarithms, so in effect this e swings down to be the base number, so it's ln 1.6, and once it swings down to be the base of the logarithm, the 10k comes down to ground level. So that tells us then that k is equal to 1 over 10, or 0.1 is 1 over 10 ln of 1.6. So there's k, and we can tap that into a calculator then. Let's do that then. So it's 0.1 times log ln of 1.6. 0.047 to 3 dp. And that was to 3 decimal places. Okay, that's that part done. So now it says find n when t is 20. In order to do that, we're going to need to find a. So here, let's use equation 1 then. So a will equal 100. And then when we do move this e to the 2k underneath, we can move it up to top level by flipping the index, can't we? So it's minus 2k. So that's a, and k is 0.047, so we can tap that in a calculator. 100 e to the minus 2 times 0.047 ... So I think I've still got that in the calculator. There it is there. So let's press answer on that. Yeah, so that's our answer. So we want 100 times e, so it's shift ln, is e to the power minus 2, negative 2, times the answer, come down to ground level, equals 91.0282. So that's to 3dp is 028, 91.028, and that was to 3 decimal places. So there's our value of a. So now we can piece together what the value for the final part of the problem is then. Find n when t equals 20. So this is at t equals 20 then, n is equal to a. We can put 91.028, that number, times e to the, what was it? Let's have a look up here. E to the kt, isn't it? So e to the k, which is 0.047, which we can put to 3dp, times the time, which is times 20. So that should be good enough. We'll just use the 3dp, I think. We won't bother trying to emphasize it's a bigger number than that. So that's just times. So let's tap that in the calculator then. So we've got that number times, now let's just write it down properly, 91.028 times e, shift log is e to the power 0.047 times 20. Jump down to ground level, press equals 233.0299885. So it's 233 to nearest whole number, because it's a unit of population. It's only a small island, so presumably this is just in units, to nearest person or number of people. Just over 233, wasn't it? So we can round that to 233 people.